Okay, so for this problem here, starting with the first one, you're finding dimensions A and B. What'd you get for dimension A? 4. Okay. How'd you get that?
24 plus A equals 28.
Okay, 24 plus A equals 28. Or you could work it backwards, 28 minus 24. The key is A is a vertical dimension, which means we can only use other vertical dimensions to find it, here and here. And when we're dealing with a piece like this, if those are all square corners, like I had said they were, the distance from the bottom to the top has to be the same no matter where we measure it. The distance from here up to here. So the 28 units here must also be 28 units over here. For some people, it's easier if you slide that dimension over like that and make it one solid straight line. So then you can see definitely that 24 and A add up to the 28. So you see 28 minus 24 gives you 4. What'd you get for dimension B? 6 is perfect. And it's the same concept there. B is a horizontal dimension, which means we can only use the other horizontal dimensions to find it. And the same thing, from this side to this side, it has to be the same distance, whether we measure it across the bottom or across the top. So B and 14 must combine to make 20. So 20 minus 14 is 6. Over here, same basic problem, just left out a couple of different pieces. Let's find C. What's C have to be? 8. Good. Same thing. It's horizontal, so we use our other horizontals. 20 minus 12 is 8. For D, what do we get? 44. Again, that's vertical, so we use our other vertical pieces. 30 plus 14 is 44. Now, the third one's a little more complex, so before we move on to that, is there anybody that's having any questions on those first two? So I think I mentioned yesterday, this is one of those skills that is extremely important in your program for the blueprint reading. But it seems to be, it takes a while for some people to develop it. So if you're struggling with it, don't worry. It's not uncommon to have problems with that. Okay, let's look at the third one here. M is probably the easier one to find. What'd you get for M? 12. Good. Same thing. It's vertical, so we deal with our other verticals. This time we have 3 pieces that have to combine to make the 26. We have the 8 and the 6. Makes 14. We subtract that from the 26 to leave us with the 12. Good. N is the tough one. What'd you get for N? 11 is perfect. There's a couple of different ways to go about finding that length N. Pretty much all of them involve having to find that distance there, which is going to be the same as this distance right here. So what I have to do is I basically have to look at this as being 2 separate rectangles. So here I've got the 12 and the 5. This has to be 7 feet, which means this is also 7 feet. Now I'm looking at this as a separate rectangle. 7 and N have to make 18, so N is 11. That is one of the more difficult things in math, is taking a larger shape and breaking it down into smaller. One of the more difficult tasks in geometry, I should say. On the algebra side, there's some different things that are more difficult. Is taking a larger, somewhat irregular shape like that and breaking it down into smaller shapes. And the one piece of advice I always try to give is do your best to break it into rectangles. Because one of the next things we do, and something we've actually looked at already, would be finding the perimeter of each of these. I think some of your homework talked a little bit about perimeter, if I remember right. How do you find the perimeter of a shape? Just add up the sides. So for this one, it's going to be 20 plus 24 plus 6 plus 4 plus 14 plus 28, which is going to give us, if we add that all up, 96 feet. So, quickly in your notes, I want you to find the perimeter of each of those two. Get rid of some of the extra stuff here for you. Okay, so for the second one here, what do you get, 128? Perfect. You might be asking yourself, how did I get that so fast just by looking at it? There's a little trick with these. If it's just a notch like that that's out, this is 14 and this is 12. Having that little notch out of the corner doesn't change the perimeter at all. So I can just do 20 plus 44 and double it. Can I do that with this one, however? No, because this has some dimensions that double back on each other. You know, this one, basically, I'm just folding that corner out, and it doesn't change the perimeter. Here, because it has a notch, I can't do that. It's an internal piece. If I add those all up, what do I get? 86, I believe? Does that sound right? What'd you get?
I got 98.
98? Okay. Sounds good to me. Yeah, 44, 88, 98, you're right. Any questions on perimeter? How many of you got all three of those right? Okay. Area would be found just by multiplying two dimensions together if I have a simple rectangle. Like if I just had, 4 feet by 10 feet, the area is just going to be 4 feet times 10 feet, or 40 square feet. I'm not so worried about the units right now, but 40 would be what I'm looking for there. Something like this, to get the area, we're going to have to cut it somehow. We're going to do that same strategy as sticking with rectangles. I just cut it right across there. So now this one's 24 by 20. Gives me 480 square feet. And this top one here is 4 by 14. Giving me 56 square feet. So that would add up to a total of 536 square feet for me. Now these other couple are a little bit more, well, this one's not any more difficult, but the third one is. Go ahead in your notes quick and find the area of each of those two for me quickly. Okay, so for the first one here, I'd probably just cut it right across there. So I have 30 by 20, which is 600 square feet. And then I have 14 by 8, which is 112. Good. So 712 square feet. How many of you had that one? Good deal. Any questions on how I got it? This one's a little bit more difficult, but I'm just going to go ahead and slice it like that, straight across. So this is 8 by 12. 96. This one's a little more difficult. We know it's 12 here, but we had to do our subtraction to find that dimension like we used before. So that's 12 by 7. Yep. And then the bottom here is 6 by 8, or by 18, I should say, which is, and we add that up to get, what, 288? How many of you got that one right? Anybody have questions on how to find those? Okay. Before we go any further, then, I want to answer questions on the homework. One's already come up on page 17. This is in Unit 2. Dealing with the dials for 27 and 28. These are actually looking at electric meters, kilowatt hours. So it measures energy use. The dial is shown below. Start with the left dial and read each dial as you move to the right. So this is the old dial meters. They actually now do have digital displays on them. But there are still several of these out there, especially in industrial settings where they haven't updated yet. Okay, so we're just recording the last digit that it is passed. So looking at this one, that first dial is between 3 and 4, so it just passed 3. Second dial, would you say that just passed the 7? Yeah. Notice that one reads backwards. It reads counterclockwise. The third one, well, it's between 0 and 1, so 0. The fourth one, between 5 and 6, so we'll call it 5. And then the last one, let's say that one's going to be a 4. It hasn't made it to the 5 yet, between 4 and 5. And all it's asking us here is if the reading in June was 35,428, how much power was used? So we're just going to subtract. We got to borrow from the 5. We got a 14. This is a 6. That's going to be a 2. Borrow from the 7 to make that a 10. This is going to be a 6 and a 1. So 1,626 kilowatt hours is what was used that month. Then we do the same down on 28. You take those readings. The top one is the beginning of the month. The bottom one is the end of the month. So you take the two readings and subtract them. Any other questions off the homework you want me to go over? 20? 17?
Yeah.
Okay. For that one, it's just a formula. Your voltage, which is represented by the letter E. If you were in DC, they would just use a V, which is more understandable as a voltage, is equal to your current, which is I, times your resistance. So for this one, they give you that the current is 8 amps. Your resistance is 15 ohms, so it's just 8 times 15 is 120. You guys used to have a science class when it was a 2-year program. You used to have a science class in your program where we went over electricity and strength of materials and stuff like that. Yeah. Now that you're 1 year, we don't have time for that anymore. Any other questions off the homework?